Alright, prepare yourself for the last bit of the review. Let's start on number 7. That's where we ended up. So what I need to do is to have a drawing of the graph. So here we have it. And this is our graph. And so what we're going to do is we're going to answer the question. During which time interval is the object moving the fastest? Question A. The answer is from 0 to 2 because that is where the graph is the steepest. And the steeper your graph, the more likely you are to have a faster speed. Alright, so part B. What is the object's motion? Describe in words the object's motion between 2 and 6 seconds. The answer is it's at rest because it stayed at 20 meters for that time period. Question C. What was the average speed for the entire 10 seconds? The average speed for the entire 10 seconds is, well, we take the change in distance at this point, and it started at 0, 0. So the change in distance would be equal to 40, and the change in time would be equal to 10 seconds. Alright, so 40 divided by 10 is 4 meters per second, and that is the average velocity. D. Describe the motion in words between 6 and 10 seconds. Alright, between 6 and 10 seconds, it's going at a positive speed because it's going forward. It's not coming back down. And it's got constant motion. Anytime the line is straight, it's constant motion. And then lastly, part E says how fast was the object going at 8 seconds. So there's where it is at 8 seconds, so we have to find the slope on this line. So it's going to be equal to, m is the slope, and that would be equal to 40 minus, 10, because we do y first. So it would be 40 minus 20 divided by 10 minus 6, and we should get a speed of 5 meters per second. Alright, number 8. Slightly tricky here, so stay with me. Alright, we have two ants, ant A and ant B, and the velocity of ant A is 4.2 meters per second, and the velocity of ant B is 3.9 meters per second. And they're going to start off across this Wheaties box that has a distance of, distance across the Wheaties box, dW, is 28.1 centimeters. Alright, we want to know, since B is traveling slower, ant B is traveling slower, we want to know how far behind he ends up. So that's going to be the distance of the Wheaties box minus the distance that ant B travels, and that will be our answer. So how do we get there? Alright, first thing we need to know is how far ant B went. Alright, so let's see what we need in order to find how far ant B went. So we've got to have the velocity for B, which we have, and the distance for B, which we're looking for, and then the time. So we need the time it took ant B to get there. How can we calculate the time? Well, the time for ant B to get to its end position is the same as the time it took ant A to get to its end position. So where does ant A end up? Well, ant A crosses the entire Wheaties box. So ant A's distance will be the distance of the Wheaties box, which means that time is equal to 28.1 centimeters over 4.2 centimeters per second, and that gives us a time of 6.7 seconds for our ant A. Ant B travels that same time. So how far did that ant go? Well, ant B can only go 3.9 meters per second, and that's going to be equal to the distance for B divided by the time, which was 6.7 seconds. So if we solve for this problem, we get the distance for B is equal to 26.13 centimeters. And if you're anything like me, the fact that I keep saying ant B is really funny because I grew up watching the Andy Griffith Show. If you didn't, you should look up why that's funny. Make you a better person, I promise. Alright, dW is the distance for the Wheaties box minus the distance for our ant B travel, and that would be 1.97 centimeters, and that's how far behind ant B was behind ant A. Alright, that answer is number 8. Number 9. coming up on the end. We have two B's that are racing to the hive. BA starts at 40 meters ahead of BB. So what does that mean? BA is going to start and have a distance traveled of this. Right? That's going to be the distance that BA travels, and BB will travel this distance. Okay? So that distance there is 40 meters because BA gets a head start of 40 meters over BB. Alright, we also know that the velocity for A is 13.6 meters per second, and we know that the velocity for B is equal to 15 meters per second. Alright, how long will it take BB to pass BA? And then also, how far will BB have traveled? Alright, so we have to figure out several things. We got to figure out the time it takes for them to catch up. And the time it should take, they should be equal, right? Because they're leaving at the same time, they're catching each other at the same time. And whenever BB passes BA, it'll be them at... Sorry, let me stop using the word be as a verb for this sentence. They will be... that's hard. They will have arrived at the same spot. So the time it took for BB to pass BA will be the time it took them to arrive at the same spot right here. Okay? So that's what we're looking for. And what that means is that time for A and time for B will have to have the same value. Alright. So also we will know this, that the distance for A will be equal, the distance for A plus 40 meters will be equal to the distance for B. And that will help us out because we can use this formula, distance for A over velocity for A, which is just us manipulating distance over time equals velocity, okay, and distance of B over velocity of B. Now I have one equation here with two unknowns, but if I use this, I can help that situation out. So what I'm going to do is I'm going to plug in this value here for dB. So I'm going to end up with dA over 13.6 equals dA plus 40 over 15. And I should be able to calculate what dA is now because I've got one equation with one unknowns. And that gives me 13.6 dA plus 40 times 13.6, which is, let's see, where did I write it? Which is 544, okay? And that's equal to 15 dA. Then I solve for dA, and I get 5444 equals 1.4 dA. And then I get that, if I solve for dA, I get 389 meters. Alright, so I'm almost there. Now I know the distance for A, and I also know the distance for B. So if the distance for A is equal to 389 meters, then the distance for B has got to be equal to the distance for A, this right here, the distance for A plus 40. So that means that the distance for B is equal to 429 meters. Okay, so now we've answered question B. So this is B. Now let's answer A. How long did it take B to pass A? Well, let's just do this quick calculation. B is equal to D over T. Alright, T then is equal to D divided by V. And so if it went 429 meters at 15 meters per second, that's the time for A, which is also equal to the time for B. And that time, it turns out, is 28.6 seconds. Alright, last question. Alright, not that difficult. An object moves with a constant speed of 2 meters per second. Sketch the position versus time graph. Basically, it should look like this. I'll give you the first few. It needs to be 10, 20, 30, should look like this, 5, 10, 15, just like that, straight line through the middle of them. Pretend that that actually hit on the line and not off the line, because it should look something like that. Okay? So that is the graph you should get. Now, the slope of that line is the speed, which is 2 meters per second, which helps you answer that little box down below. And then also, the value for b is just this formula, y equals mx plus b. This intercepts at 0, so b value is 0. Alright? Hopefully this helps you. If it doesn't, I apologize, but I have tried fairly hard.